All right. Hello, everybody. So go ahead and get your stuff out. So tonight's video or session or whatever, I've already got all of these worked out. So I'm just going to go through, just show answers. The idea is that you guys hopefully have done all of these and you can check your work with what we have here. Ask questions. We'll go real slow. There's no race, but we'll just slowly go through everything you had. And if it all checks out for you, then that's fantastic. And it's okay also if it didn't, or if you didn't know a couple. This is just going to be like a 30-40 minute session for you guys to just check your answers and ask lots of questions. Don't sit there quietly. So if any part of this doesn't make sense or whatever you would like to do, that's what we're going to do tonight is just go through these. So I'll just scroll. I don't think you need me to read the math to you. You can clearly see it. So I'll just leave it up here for 20-30 seconds. Just say stuff if you want to say something. This is just a good night for conversation and checking this out. So here is part A of number 1. And this is also being recorded, so this will be posted online with the rest of them. So you're welcome to go back and pause the video to check these. Anybody with any questions, anything?
Mr. Baker,
Yeah.
can you please explain why you simplify, why you're able to simplify the e to the power of natural log 800 to just 800? I didn't get that part.
Hold on, let me get caught up. Over here.
Yes, sir.
Um,
Like right of the line above. It's
yeah. Okay, so right here. So that is an E and a natural log rule. So one of the rules that we need to know. So for natural log, I'll put it down here. There's basically 3 big rules. You need to know that natural log of 1 is equal to 0. You need
mhm,
to know that natural log of E to the stuff is the stuff, and E to the natural log of the stuff is the stuff. So these 3 rules are real big when you're doing this. So for the one you asked me, this third one, E to the natural log stuff um, is how that is turning into 800.
okay, thank you.
Mhm. Okay, let's take a look at letter B. Rayanne, what are you saying to me? Say that again. I just saw your message. I I don't know. This is all I have for the work right now. But you're welcome to just take a picture of this and come see me in class. We can figure that out. All right. So for B, C, we have that on the board. Um, Judah, to answer your question, K is part of the formula for um, the variation when it varies directly with something. It's kind of like an algebra 2, y equals kx, except in this problem now it's calculus. It's the rate of change varies directly with 500 plus F. So that K kind of goes back to the direct variation representation.
Mr. Baker, I have a question.
Yes.
So in part A, can we also just divide by F initially so that on one side we would just have natural log of F? And then
Can't divide by F because this is 500 plus F.
I thought that was a like a T for time.
Oh, no. So it says it was, yeah, this is 500 plus F. If what you described was a T, then yes, definitely could be that. But yeah, in this case, that's a plus sign. Okay, guys, so that is the conclusion of number 1. Let's look at number 2. Okay, consider the differential equation, all that good stuff. Let y equals f of x be the particular solution with an initial condition of f of 0 is equal to 1. So this is a previously asked FRQ that would be BC FRQ type. So for part A, it asked us for the limit. And I actually didn't write this out as properly as I should have. When you're doing the L'Hopital's rule, like I showed you in class, we should write the limit of the top and also the limit of the bottom. So the real notation for that would be the limit as x heads to 0. So they want you to show both of these. The reason for that is that I did this answer key last year, and I just recently learned that in order to get full credit on L'Hopital's rule, College Board requires, to me, this means the same thing, but they are very picky about that. So I just discovered that little tidbit recently, that you need to write this limit out individually for the top and bottom where they take a point off of you. But other than that, the rest of this is all good. So you would do L'Hopital's rule, and we should be coming up with 2 for an answer. Part B, use Euler's method, starting at x is equal to 0 with 2 equal steps to approximate f of a half. So I will let you check out that answer and see how that goes. Any questions on the Euler's method problem? Three triangle dots means therefore. Okay, and in part C.
This was one I definitely had a little bit of trouble on. Can you walk us through what like the particular solution means, like how we should be plugging that in?
Yeah, so this is going to make 10 times more sense to you after Tuesday's lesson in AB because we're going to start differential equations. You're kind of doing this on the fly right now without a formal lesson. So once you have the Calc AB lesson on differential equations, this will make way more sense. Basically, what you're doing is our goal is to split the variables. We put one on the left and one on the right, and then you integrate both sides. So I split this up by putting the y squared on the left side, the x stuff on the right side. And then you go through and you integrate. And when you do that, we only put plus c on the right side. And so the first thing you do is you solve for c by plugging in the point. So they gave us this point, which is x is 0 and y is -1. So over here, I was putting in -1 for y, 0 for x, which disappears these two. And when you do that math, you come up with c is equal to 1. And then once you have c, we go back to, so this line right here, the initial thing you get when you integrate, that is called the general solution. And what you do is after you find c, we go back to the general solution and we replace c. And now you solve the equation for y. So the particular solution is the general solution solved for y after you figured out what c was. And that is this one over here. So when it asks for a particular solution, that means you solve the general solution for y after you figured out what c was. And to figure out what c is, you use the point that they are given. And don't get too blown away by this problem because in a week or so, this will make great sense because we're going to do a whole bunch of these. This lesson is, you got to keep in mind that all of these lessons you guys are doing right now are supposed to come after all of AB has been taught. So this order is a little all over the place right now. So we'll fill in the gaps with this on Tuesday in class. Any other questions on that one, guys? Okay, coming in at number 3, I think this might have been from 2017, Calc AB, but this was an actual free response question that had been asked. So for part A, I'll let you guys take a peek there and tell me what you think. Okay, for B, okay, part C.
For your proof, do you have to show the actual number itself or just if it's negative or positive?
You do not have this piece right here. As long as you just say positive or negative, you're good on
Okay.
that. They don't need
Alright.
the exact number.
All right. neat.
Is this something you plugged into your calculator?
This is actually a non-calculator question because all of these are pretty friendly formulas. So this was actually in the non-calculator section.
So I like integrated like I actually did all the integration for velocity and I got that acceleration was positive. Can you show how you got your acceleration?
Yeah, so what are we doing here? This is for Q. So what did they give us for Q? Up above, they told us that VQ of T was equal to T squared minus 8T plus 15. So AQ of T would be the derivative of that. So that's 2T minus 8. And then this is being done at 2. So that's this math over here. AQ at 2 is -4. So basically, we just needed to take a derivative of their velocity formula for Q. We'll do this question eventually in class. A big thing with this one. So when you read this question up above, the first thing I noticed was, okay, we have particle P and we have particle Q, and I've got stuff going all over the place. So when that's the case, I would make a list that says Q and P and just write out all the formulas you can and get all the information collected that you can for these two formulas. And then once you kind of have a key set up, then you can go from there. Okay. Letter D. Find the position of particle Q the first time it changes directions. That is shown on the screen. This is non-calculator, Caleb. This whole question would have been non-calculator. So we would have actually been doing this math in this question. Okay, anything else on this one? Okay, so let's see where that takes us here. All right, number 4. Okay, following that up. Any questions on 4? Okay, number 5. So this is your logistical differential equation. So we got 100 wolves and 50 wolves for those answers. All right, number 6. Number 7.
Can you go back up real quick?
Mhm. Okay, number 7. Number 8. Okay, number 9. So this would fall under the AB category, really. Some of these questions in the BC review, I try to sneak some AB stuff in there as well. Number 10. Any questions on number 9, 10, anything you see? Okay, slide number.
Mr. Baker, I have a question.
What we got?
So, I use a different method to solve like Euler's method problems. And so if I use a different method, that like does AP like have a standardized method, if that makes sense? Like would they mark me wrong if I use a different way?
What you doing?
Sorry, can you repeat that?
I said, what are you doing?
So instead of have like what I do instead is I take the previous y value and just add it to dy dx of the previous values multiplied by the step size to get my new y value, which is similar.
Yeah, I think that should work. You're getting the same answer, right?
Yeah.
Show me in class tomorrow or Tuesday and let me see, but I don't see why that would be a problem as long as you're coming out with the same thing.
Okay.
Hold on, what's going on in chat here? Sorry, guys, I wasn't reading chat. You guys gotta talk to me. I don't see this chat stuff all the time. What kind of questions did you guys have in chat? Auburn, did I skip a page?
Your question numbers just don't match up with mine. I just assumed it was me.
Oh, they're not the same numbers?
Mm-mm. That's number 14 on mine. What your number 11 is.
But there is a whole page that's missing now.
Uh-oh.
Like it's in our packet, but you don't have it.
Is it this one?
Well, Taylor, is it
Well,
number
it was the page right after the two particles problem.
Yeah.
It just had like integral stuff. It wasn't actually that hard. It was just like integral view.
It was
These
one
ones?
integration by parts problem followed by a
No,
decomposition problem.
different integrals one. It was like listed as 4, 5, 6.
Oh, okay.
It starts with 3x natural log of x for the
That's the
integral.
first problem.
You guys gotta yell at me. I wonder if I copied the wrong one. We're pretty similar though, is that correct?
No,
You said-
like you had everything that you've
Hold on.
shown has been something that
Oh,
we
hold on.
Oh, there- yeah, that's it.
Hold on. Is this
That's
the
the
page?
one.
Maybe I missed the page.
That's the one.
Is this
Yeah,
what we're missing? Okay, here we go. Sorry about that. All right, so go ahead and you can scan through these. Okay. Next one. Ray, and to answer your question, those two things mean the same thing, so you could use either one.
For my first term, I got 25/26 instead of over 13.
So let's just start from the beginning here. Did you get A and B to be the same? You got 25 over, you didn't have 25 over 13, is that what you're saying?
For my final answer, no, I had 25/26.
Let's see. So to solve for this, we got to plug in 5/2, right? And if you plug in 5/2,
Yeah, well, I had 25/13, but because this natural log of 2x minus 5, I thought we would have to like divide by 2 to get rid of like a x or 2 in the numerator.
Yeah, we could have done that. That's true. I'll show you guys in class. Yeah, there's two ways of thinking about that. I see what you're saying. For right now, that's okay, but yeah, I see what you're saying. We can take a look at that. It'll, when we go through differential equations as well, that'll help out. But yeah, that's a good catch. For the last one, you got a final answer here that looks like something like that. X to the third over 3 plus 3x squared plus 21x plus 85 natural log x minus 4 plus c. All right, we're just about there, guys.
Would that be under multiple choice or free response?
Multiple choice?
Okay.
So we did 11, 12, is that correct? On this page?
Not 12, just 11.
Okay. So this is mean value theorem. This was a previously released question from an AP exam, so they asked this exact question. All right, and last couple.
For the test, would it be worth just memorizing the derivative of, arc sine, cosine, and stuff like that instead of having to solve it? Or would they grade you based on how you solve it?
I think this is all multiple choice, so I don't know that it would matter. Yeah, if you just know it, I think you're good.
Okay.
And our last one.
Can you do this one with U substitution?
Let's see. Let's try. So that would give us what? 2x over u du over 2x Yeah, that looks reasonable to me. And then those would cancel. Yeah, the only thing here is that when you go to integrate this is gonna be natural log of x squared minus 9. So if you go that route, we just need to kind of play around with logarithm rules, because these two answers would technically be equivalent, because this is really natural log. If you factor this, x plus 3, x minus 3, and with logarithms, things that are multiplied, you can rewrite them as separate logarithms with addition. So these two answers are equivalent. So in multiple choice, depending on what answer they gave you, you would just have to make sure you understood that they were equivalent. But yeah, other than that, I don't see why not. Okay. So I think that's a pretty good update for you guys on where you're at. These are never going to be 100% perfect, but if the majority of what you're seeing on the screen is checking out and 80-90% of it is clicking, that is going to be a very good place. Keep in mind that the exam is still like 70% AB. So if just the majority of the BC is making sense, I think you'll be in a good place. Do you guys have any questions? Okay, then I will get this posted in the next couple minutes, and then on Tuesday in class for AB, we'll actually be starting the differential equations part of the year. So that'll tie together a lot of this for you guys, and then we'll go from there. So tomorrow night we will meet at 8:30 to continue our BC journey, and then we'll go from there. So I will see you guys tomorrow night at 8:30.
Thank you.
All right, see ya.
Bye.
Thank you. Good night.